Another application of operation amplifier is a subtractor amplifier. As the name suggests, it will be doing the operation of subtraction. So, for subtraction we need minimum 2 voltages. So, you can see the circuit diagram. This one is used to subtract 2 voltages. You have 2 voltages. V1 is applied to the non-inverting terminal and the voltage V2 is applied to the inverting terminal. So, output voltage we should get as the subtraction of V1 and V2, that is output voltage will be equal to V1 minus V2. Now we will see how we can derive that expression. So this is the circuit diagram we have shown, and the two voltages V2 coming to the inverting terminal, V1 applied to the non-inverting terminal. Now for deriving it, as we have given two voltages, we have to use superposition theorem. Superposition theorem means at a time one source will be active, other will be equal to 0. So, and you have to add the individual response of each voltage, you will be getting the total voltage. So, the first case, take the voltage V2 is active, that means V2 is there, V2 is active and V1 is equal to 0. That means the non-inverting voltage, assume it as 0. So, this is 0 means this is grounded. Now, let it be the output or effect of only due to V2, I am just marking it as say V01. It is only due to the effect of V2 alone. So, what is V01? V01 is the input V2 is applied to the inverting terminal, the feedback resistance is R4, input resistance is R2. So, your output voltage will be equal to minus, as it is given to the inverting terminal, it is minus R4 divided by R2, that is the gain of the amplifier multiplied by the input voltage V2. So, V01 is minus R4 by R2 multiplied by V2. Now, for the second case, you consider that V2 is equal to 0 and V1 is active. That means keep V1 alone there and keep V2 equal to 0. Consider the output due to V1 alone is say V02. And so V2 equal to 0 means this terminal is going to be the ground and you have only now V1. So V1 is applied to the non-inverting terminal. So you are say the voltage at this point, I just marking the voltage at this point is say Vp, positive voltage. So the output voltage V02 will be equal to 1 plus R4 by R2, that is the gain of the non-inverting amplifier, multiplied by the input voltage Vp. Now, what is Vp? Vp means the voltage across the resistor R3. So, I can write as Vp is equal to VR3. What is VR3? That is the voltage you are applying here is V1 divided by R1 plus R3, that is the current multiplied by R3. So, VR3 I can write as V1 divided by R1 plus R3 multiplied by R3. Substitute the value of Vp what we are getting over here to this expression. So, I can write as V02 is equal to 1 plus R4 divided by R2 multiplied by your Vp is V1 divided by R1 plus R3 into R3. That is equal to V02 due to your voltage V1 alone. Now, what is the total voltage V out? V out is V01 plus V02, the effect of two voltages together. So, I can write as, now here I am going to write the final expressions. V out is equal to, the actual output voltage is equal to V01 plus V02. Now, what is V01? Just go back to the previous slide. V01 we derived over here as minus R4 divided by R2 multiplied by V2. So, I just substitute that value over here. V01 is minus R4 divided by R2 into V2. Now, what is V02? This is V02. So, V02 is 1 plus R4 divided by R2 multiplied by V1 into R3 divided by R1 plus R3. Now, take the case as all the resistor R2 is equal to R4. So, now just assume that R4 is equal to R2. That means the feedback resistance and input resistance are equal. Also, R1 is equal to R3. So that your output expression now becomes V out is equal to R4 equal to R2 means you will get there, both will cancel, you will get minus V2 alone there, plus 1 plus R4 by R2. R4 and R2 are equal means that is 1. 1 plus 1 will become now 2 into V1 R3 divided by R1 plus R3. R1 and R3 are equal. So, it is this is 2 R3 I can write. R3 cancels. I can write it as, so this is R3 by R1 and R3 are equal. I will write here as 2 R3. Now, R3 cancels. 2 cancels. I will get alone V1. So, it is minus V2 plus V1. It is, this all are in one, okay, one expressions. That means you can write your final V out as V1 minus V2. This is nothing but the subtraction operation. See here, V1 you are applying to the non-inverting terminal, V2 you are applying to the input terminal. So, the output will be non-inverting terminal voltage minus inverting terminal voltage. So, these factors are the gains associated with the voltages. So, if you want to get exact subtraction of the input to voltage means you need to provide all the resistor, all these two resistors equal, these two resistors equal. Otherwise, the gain associated with that you will be getting. So, this is the subtraction operation using an op-amp. So, for this we used only a single operation amplifier circuit. With a single operation amplifier, we subtract two voltages. Now, this is another circuit for doing the subtraction operation. This is the same you have done in the lab also. Same circuit. This is an inverting amplifier This is from the circuit, this is a summing amplifier. So we have derived in the lab these expressions. So this is the another circuit for doing the subtraction operation. Now we'll see how to derive the expression for the output voltage for this circuit diagram. So mark here, say the output of the first amplifier, mark it as say V01. So what is V01? V01 is equal to minus RF by R1 into V1. And see, this is a summing amplifier. The two inputs of the summing amplifier are, one is V01, that is the output of first inverting amplifier, and other is V2, that is the second input. So the output voltage V out, I can write it as, it is non-inverting terminal is grounded, so it is minus RF divided by R3 multiplied by V01 plus RF divided by R2 multiplied by V2. Substituting the value of V01 over here, we'll be getting it as minus RF by R3 into V01 is minus RF by R1 into V1 plus RF by R2 into V2. Multiply inside the minus, minus into minus become plus. So your expression become RF into RF divided by R1 R3, this alone, minus and minus cancels, into V1, minus into plus become minus RF by R2 into V2. See here, if the resistor RF and R1 are equal, also RF is equal to R3, also RF equal to R2, all resistors are equal, you will get the expression as V1 minus V2. The same thing only we have derived in the lab also. We have done in the lab an expression 7Vi1 minus 4Vi2. This is the way we have done that.